Welcome to our video on solving a proportion using equivalent fractions, which means, as you can see right here, that you're going to solve for a missing part of one of the fractions. And remember, proportions just say that, for example, 1/2 could be a fraction, and that if I had a missing number over 4, what number would I put here so that this fraction equals this one? Well, the answer is 2, right? In this case, it would be 2. So what number do we put in here to get equivalence? Here's some different ways to solve it. Let's start with this color over here. One thing I would do is, I think it's easy to see from my perspective. If you take 27 and you divide it by 3, you get 9. Well, if I'm changing the denominator by taking the number and cutting it in 3 parts, I should do the same thing up here. So this missing number should also be 9 divided by 3. Just like 27 was divided by 3, and in that case x is 3. And that makes sense because 3 over 9, which is 1/3, is the same thing as 9 over 27, which is also 1/3. Another way of solving it, in blue, and it happens, I think, to use the same multiple here, which is interesting. I wonder how often this happens. So you take 9 and multiply it by 3, you get 27 times 3. Well, this fraction should have the same relationship because we're saying they're equal. So what number times 3 gives us 9? Well, that's 3. So x is 3. A third way of solving it, in pink. Now this is often referred to as cross multiplication, but let's go over it. What I would do is multiply both sides by 27, but really you can think of just crossing it like this. So multiply this side by 27, and then I'd multiply both sides by 9, but a quick way of thinking about that is just multiply this side by 9. So that gives me what? Well, 27 times x, whatever that is, equals 9 times 9, which is 81. And then we have this equation. 27 times something is 81. Well, using our fact family idea, we could say that 81 divided by 27 gives us the unknown, right? Just like if we had, for example, 2 times 3 is 6. Well, then 6 divided by 2 would give us 3. Same thing here. 81 divided by 27 will give us the unknown. So that's 3. So x equals 3 in any way we look at this. And this type of problem could take other forms. Here we have Carlos burning 75 calories. So 75 calories for every 15 minutes he walks. I'm going to write that as a ratio. Okay, that's what they're saying. It's 75 calories for every 15 minutes. How many calories will Carlos burns if he walks for 45 minutes? Okay, so that's where we can use a proportion. Well, if it's 15 minutes for 75 calories, what would it be? We're assuming he's burning at the same rate for 45 minutes, right? We're putting 45 minutes down here in our denominator. What goes up here, right? How many calories will be for 45 minutes? Well, I would say since, right, if you notice, 15 times 3 gives us 45. Well, then the number x should be 3 times greater than 75. So since 15 times 3 gives us 45, we're trying to keep this proportional. 75 times 3 should give us x. And therefore 75 times 3, which is I think 225, that's our x value. So x is 225. And we can also check it this way, right? 15 times 5 is 75, isn't it? Yes. So 45 times 5 should give us 225, and it does. So we can check across these fractions in the proportion or up and down. And what we should see is that if they're equal, the numerators and denominators, when we divide them or multiply them in some order, we should get the same number on both sides. And then we get this question where it says, Carlos wants to burn 300 calories. How many minutes must Carlos walk in order to burn 300 calories? Okay, well how do we do that? Well, if 75 calories, or 75 C for calories, over 15 minutes is equal to what? Well, now he wants to burn 300 calories. How many minutes is that going to be? Well, what we knew from before was that 15 times 5 gave us 75. So our mystery number times 5 should give us 300. So our question is, what times 5 gives us 300? Well, we can just take 300 and divide it by 5 to find out the answer. And which is what? Which is 60. So the answer here is, it would be 60 minutes of walking to burn that many calories. And again, when you set this proportion up, I could have reversed it. I could have written 15 minutes over 75 calories and done the same thing here. Just set your proportion up. Choose one. They'll give you two types of units. Put one in the numerator, the other in the denominator, and set up every fraction in the same way, and you can easily compare them. Alright, hope this helped.